Alright guys, as we're done Unit 4, let's go ahead and do the review. So Unit 4 was a very short unit, we only had 4 lessons. However, next unit we're going to talk about trigonometric functions, and oh boy, we have 8 lessons, which is just 1 lesson less than Unit 1. However, after that, we're actually kind of off to the easy stuff, and that is pretty much going to be the end of this class. I can't believe it. So let's go ahead and let's solve this triangle. So solve each triangle this they gave us to. So let's go ahead and do that. Let's draw out the triangle first, obviously. Usually we will always do that. Let's see, A, B, C. So if A equals 9, oh, sorry, there's a 90 degrees triangle here. So 90. And then this is A, right? This is A, so 2.5. And then this is A right here. And then 1.6. It doesn't really matter which one. So now let's go ahead and see what we can do here. So right there we can see we can find the other side by using the Pythagoras theorem. 2.5 squared minus 1.6 squared. It's gonna give us 2.56, and so it's gonna give us 3.69, and we square root that. It's gonna give us 1.92. Then let's SPECTATOR. So sine of this equals opposite over hypotenuse. So 1.92 divided by 2.5. 1.92 divided by 2.5. Then we're gonna go ahead and inverse sine that. Inverse sine of answer. It's gonna give us 50 degrees. 50.2 degrees. And then 180 minus, so 90 minus 52, 50.2, 39.8. And therefore we have it. So the triangle. So I'm actually not going to do the second one just because, hey, this is super easy. You should be able to do that on your own. I'm going to go ahead so we can have some time to do the hard stuff. Oh, that's not what I meant to do. So, okay, so let's go ahead and do question number 2. So we want to find the length of DE. So let's see how would we go ahead and do that. So remember this little square, it means we have a 90 degrees, just so we know. Okay, so let's see. DE, how are we going to use this to find DE? So first let's find, what can we find here? Let's find, this is 11.1. Okay, so unfortunately, even though we're given a lot of information, we have to go ahead and draw another triangle. So let's draw a line here. So if this was 11.1 and this is 14.3 and this is a right triangle, what does that mean? Pythagoras theorem. Let's go ahead and do that. 14.3 squared plus 11.1 squared. And then we're going to square root that. So 18.1. Okay, wait, why did I do that? Yeah, why did I do that? Okay. Yeah, I don't know why I did that. So, let me just refresh so I can actually. So, I don't know why exactly I did that, but let me just erase all of this first. So we actually have an eraser, I just never use it. So, pencil. Okay, so essentially we're gonna go ahead and find CD first. So you might ask how we do that. Oh wait, no, we have to find the angles first. Yeah, so let's go ahead and find the angle of C. SPECTATOR. Sine of C equals to opposite over, let's do cosine, yeah. Cos C equals to adjacent over hypot. 7.5 over 11.1. Then inverse cosine that. 47.4. 47.5, rounds up, sorry. Now let's do 180 minus 90 minus 47.5, 42.5. So we have this angle on the other side, this angle here. This angle, this is equal to 42.5. So now we have that, we can actually go ahead and do some sine law. ED over 14.3. So ED is equal to 9.66 to 9.7. 9.7, so yeah. Okay, yeah, so always when you see these type of questions, give it a try, do some funny stuff. If you can't do it, try another way, and that's how you do it. So 3, I'm going to do it real fast, like very fast. Wow, what am I drawing? Negative 12, 9, so here. Let's find the hypotenuse. 15. So sine opposite over hypotenuse. And therefore we found it. Now let's go ahead and do 4. Okay, I can't do 4 for you. It's just calculator. So let me just, you know what? I'm gonna do that. Sure, why not? Sine of 82.3 degrees. It's gonna give you 0.9909 or 0.991. Cos 19.9 degrees. It's gonna go ahead and give me 0.9403, which is rounded up. Sine of 149.5 degrees. That's gonna go ahead and give me 0.5075, no rounded. Well rounded, yeah. Cos of 159.2 degrees. It's gonna go ahead and give me negative 0.9348. So let's go ahead and look at question 5. Find the angle A. So basically we're doing the inverse. So So 0.6678 inverse sine of that. Oh. It's going to give us 41.897. I'm going to do 9 degrees. 1/8. So we're going to find the other one. So use the related angles. 138.1. So these are the two angles. And then for B, just do the cosine on your own. Pretty simple. That's CC. If the sine of an angle, if the cosine of an angle is negative, can the angle be acute? So remember this. Oh, student, take calculus. So in quadrant 1, this is 0 to 90 degrees. Remember? So this is 90 degrees, this is 180 degrees, this is 270, this is 360. So within the first quadrant, everything is positive. So no, the angle cannot be acute if cosine is negative. If sine is 0.3781, can the angle be obtuse? Absolutely. So sine is positive in both quadrant, and if we have a positive there, it could be either in this or in this. However, realistically speaking, it probably exists in both of them. Solve each triangle. So I'm not going to do this. That's just simple sine law. It's pretty straightforward. I want to go ahead and do some word problems with you guys. So A, B, C, D, E. Yeah, E and F, just draw it out yourself. Make sure to draw it carefully and try your best to draw it to scale. So, inaccessible cliff. To measure the height x1 of an inaccessible cliff, a surveyor, or whatever you pronounce that, recorded the data shown below. If the height of the theodolite used was 1.7 meters, find the height of the cliff. Okay, so for those that don't know, I kind of want to translate to tell you guys what a theodolite is, because I personally, when I first saw this question when I was doing it, I was like, hey, what the hell is a theodolite? So theodolite is it's this little machine that they kind of try to use. They try to use to basically measure angles between visible points in the horizontal and vertical planes. So essentially, it's trying to, well, I guess measure stuff. So it was used a long time a while back. Now they use kind of satellites to do that. So we just technically ignored the height that they gave us. Let's just solve the triangle. So we want to find x, y, right? So I'm going to go ahead and break these two angles down. Break these two triangles apart. And this angle was 31.1. And then the other triangle, $35.8 and 44.2. Alright, so let's go ahead and solve this. How do we find xy? How do we find this height? How do we find this height? Well, we're supposed to need this. And this is the same thing as this, right? Let's go ahead and find it. So let's find this first. 180 minus 35.8 minus 44.2. It's going to go ahead and give us perfectly 100. And remember that, let's go ahead and do the sine law. So sine of 100 degrees over 90 is equal to x over 44.2. So sine 44.2 over x. Let's go ahead and find it. Let's go ahead and calculate that. Sine 44.2 degrees times 90 divided by sine 100 degrees. It's going to go ahead and give us 63.71. Right? 63.71. So I rounded it here, but I actually didn't round it on my calculator because I kind of need, I'm going to save it, right? I want to save it for the next step. So now let's see. How do we find this in a right triangle? So sine of 31.1 equals to, oh wait, sorry, cosine of 31.1 is equal to the angle we found earlier, which is adjacent over hypotenuse, which is x, y, essentially. So we're basically going to do the number we found earlier divided by cosine of 31.1 degrees. So let's do that. Finally, xy gave me 74, and then let's see the rounding. Round to the nearest tenth of a meter, 74.4 meters. Alright, so that is that. Let's go ahead and do question number 11 or 10. Determine the number of triangles that could be drawn within it. Then find the measures of the other angles on the other side of each pillar. Okay. So I'm actually going to draw it out for you. So you guys have to actually do the math technical stuff because drawing it out is the hard part. So this is 5, this is 3. So we can create two solutions. So for question number A, two triangles, two solos. For question number for B, so we have S being 3.5. This is 29 degrees. So S is over here. So S is 3.5. So S is somewhere here. So this is 3.5. And that's 6, right? 66. So we can still also create 2. See. Big X sits in here with 90. Oh, well, okay. So big X sits in here with a 96-degree angle. And then our small x, which is this, is 2.5. And this is y, so 0.8. So looking at it and be like, hey, how many angles can we create? How many triangles can we create? Well, if you swing it on that side, it will work, but this wouldn't be the angle anymore, so we can only create one. One solution. Let's see D. G is 41.7. G. And then we have G here, which is 7.2 and 9.9. 7.2. So we can look at it and be like, oh, like, okay, G is smaller than H. What does that mean? 2 solutions. And we're done. So I actually just draw it out for you, but you guys have to actually solve the triangles and find all that. It's just stupidly. It's a lot of work. It's not hard. It's just a lot of work. The distance between the centers of the circles A and B is 60 meters. So AB is 60 meters. Each circle has a radius of 40. Point C lies on the where's point C? Lies on the circle with center B. Okay, so let's kind of draw this out. So this is 60, and so it lies on the circle. So it's on the line, I guess. So it's on C. So here, somewhere here, it's on C. But BC, since that's the radius, that's 40 meters. Here is 41. So let's see. How do we solve this? What are the possible length of AC? Okay, so this is just an ambiguous case. So they want us to solve it like this. Let's go ahead and use the sine law. I'm going to do theta here over 60. Let's just go ahead and do 60 times sine of 41 degrees divided by 40. And then inverse sine of that. 79.7654. So I'm just going to round that to 79 point what? 79.8. That's right here. So we're trying to find the value of, I guess, this entire thing. So if this angle is 79.8, we can find the value of, let's say, this part. So we're gonna do what can we do here? We can find the top angle. So 79.8 times 2, and then 180 minus 159.6, so 20.4 is the top. So essentially we have this. Sine law that over what? Over x is equal to sine of 79.8 degrees over 40. Let's find x. So sine of 20.4 degrees times 40 divided by sine of 79.8 degrees. 14.16. X is equal to 14.2. Okay, so we found x. Now what can we do? We gotta find this part as well. So I'm gonna keep in mind that x equals 14.2. So let's go ahead and find this part, I guess. So how do we find that part? So let's see if we can use any laws here. Let's drag that angle outside. Sorry. So if you remember, this was 79.8. And inside here, this was also 79.8. What does that mean? We can do 180 minus 79.8 to find out the angle right here. This is 100.02. 100.2, yeah. So now let's go ahead and sine law this entire thing once again. Okay, we can't do it yet. So we have 102. So and we have 41 here. So let's find the missing angle. 180 minus 102 minus 41. It's going to give us 38.8. 38.8. So now we can finally sine law this. So sine of 100.2 over 60 is equal to sine of 38.8 over x. And let's go ahead and find that. So sine of 38.8 degrees multiplied by 60 divided by sine of 100.2 degrees. It's going to go ahead and give us 38.2. So, finally, with that said, the length, our AC, could either be this triangle or this triangle. So for this triangle, our length is 38.2. And since we found this part here, we can just add it to this part. So 38.2 plus 14.2 is going to give us 52.4. And with that said, that is the end of chapter 4. I will see you guys in trigonometric functions.